Surds are, of course, an irrational number. We don't know what they are exactly. So any number that includes that radical symbol is a surd. Well, sort of. It has to be one that can't be calculated exactly. So square root of 4, even though it has the radical symbol, is not a surd because we can simplify that and get rid of the symbol. Square root of 4 is 2. So any of the ones we can't work out are surds. There's some rules, some laws to manipulate surds. This is the one we often use to simplify them. We can say, well, the square root of AB is the square root of A times the square root of B. Similar one for division. And the third one is basically squaring and square rooting are inverse operations, so they cancel each other out. A couple of quick examples. Square root of 50, the idea is we want to break it into 2 factors, one of those factors being a perfect square. 50 is of course 25 times 2. Again, you wouldn't necessarily write that, but that's what we're thinking, and we know the square root of 25 is 5, so we get 5 root 2. Square root of x cubed, we talked about this one when we were looking at index laws before, but we need to simplify this surd, remembering x cubed is actually x squared times x. There's your perfect square. Square root of x squared, well, technically, it's like I mentioned the other day, technically it's actually the absolute value of x. Root 5 on 4, well, we can work out the square root of 4, we just can't work out the square root of 5, so root 5 on 2. Root 20 on 9, we can work out square root of 9, and we can simplify the square root of 20, so we get 2 root 5 on 3. So surd arithmetic. Very similar to the very first bit of theory we had this year. The only difference is I've written the word surds instead of the word terms. You see, algebra, we're dealing with unknowns. Surds are unknowns. So the rules are exactly the same for algebra as they are for surds. In this case, we're looking at it and going, well, square root of 3, they're like surds, we can add those, and the square root of 2, we can do that as well. So that's the same as algebra. Expanding this out, well, it's a binomial product. First outside, inside last. Nothing simplifies with this one. Difference of 2 squares. The reason I picked these ones for difference of 2 squares, well, any difference of 2 squares for that matter, you have a situation where we have conjugate surds. So conjugate surds are where we basically have the same terms, but the sign in between them is different. So one of them it's a plus, one of them it's a minus. We call those conjugates. So difference of 2 squares, 2 minus 1, we get 1. A perfect square. So a squared minus 2ab plus b squared. Of course, the 4 plus 2 we can make 6. So 2c, 2d.